Hi, AP Physics kids. It's me, and I'm back to talk a little bit about the multiple choice questions from Unit 3 that was assigned last week. I plan to continue to do this even though we've gone to the choice board assignment for this week, because at the end of the day, if you guys watch this and you go back and review and create some review materials, even just a one-pager for each and every unit from Unit 1 to Unit 7, it's something that you guys can use on the AP exam, and I truly believe because they're keeping the multiple choice questions on the lockdown browser, they're probably going to use some of these questions as a free response question of some sort. So I picked out some of the ones that I think are most important from Part A and Part B. So I'm going to do this review in two parts. And basically we're going to do exactly what we did last time, go through the ones where a majority of the class got them wrong, kind of like number 2 and 3 here. And then if there's any other questions, please refer back to me. I've also created 2 posts highlighting some labs and some AP review videos that I think are really helpful for this section. So it doesn't hurt to go back and watch those again, whether you do it this week or the week before the test, just to put that stuff fresh in your brain. And I had comments from kids, I don't remember how to do this. I do not remember it. I need to go back and relearn it. And those are good identifying traits. You guys are self-reflecting on your learning process and then deciding, hey, I do need to fix this and I do need to go back and find some resources. So if you're having trouble with that or you need help with that, please seek me out for help. I will point you in the right direction, or we can do a Zoom and talk more about that. Okay. That was my intro. Let's get on to the questions. So question 2 here deals with satellites in orbit. So I want to just point out to you guys that satellites in orbit, the only force that's holding them in centripetal acceleration is gravity, okay? When we think about putting like a string on the end, or a marble on the end of a string and whipping it around, tension is the only force that's holding it in that orbit, if we say that other things are negligible. So this is kind of the same type of problem. Putting a kid on a merry-go-round and whipping them around, again, friction's what's holding them in that orbit around the center of the merry-go-round. So at the end of the day, the only difference here is the real live force holding the satellite in orbit. So in this problem, the big thing that you're asked to think about is what happens if we increase the radius right here, or in this case, you see this 2, that number is really important when we start to think about factor of change. If we double it, what would happen to the overall centripetal acceleration? So here you guys can see your answers. Most kids picked 2, so they divided it by 2 because it was doubled. But keep in mind, guys, when we are using the universal gravitation law, Newton's law, and Newton's second law in combination, that radius is squared. And so that's why we see that it's actually divided by 4, because our radius becomes 2 raised to the second power. If you go through and read the rest of it, it shows how to do the derivation for the free response questions for Unit 3, deriving an equation for planet B and C and planet A and the stars and all that other stuff. This is a great one to go back and look at, because this basically is using those same concepts where we have a Newton's second law, force, centripetal force is equal to mass times acceleration, and we're setting it equal to the universal law of gravitation, where gravity is really the only force holding that object in its orbit. So I do expect to see this one somewhere in your free response. It's such a huge concept, and it's, again, a place for them to look at Newton's second law, energy, forces, free body diagrams. So this is a good one to go back and review. All right, number 3. Okay, this one I saw in our Unit 3, number 1, the question that was similar to the flying pigs. A lot of you guys kind of made this same mistake, where we're trying to identify objects that we need to measure to collect data. So when you read through this, it was really good. A lot of you guys picked out that you definitely need a meter stick. You definitely need a timer. But then you added all this extra stuff. And remember, if we have a spring scale, as they do in this case, if we've got a spring scale, we don't need the extra stuff. A meter stick and timer are also going to do the same thing as a motion detector. A mass balance is going to do the same thing as a spring scale. A protractor, don't really need it because we can do trig functions and we can use tangent, cosine, and sine to determine an angle. And really in this case, there is no angle because it's on a 90-degree axis. Remember, inertial mass is the mass when it's perfectly horizontal. Gravitational mass is when it's perfectly up and down vertical. So if those two words, and I was just looking for where they're at in the problem, if those two words kind of threw you off, go back to Unit 2, I believe, is when we talked about inertial mass compared to gravitational mass. All right. Geez, I have the worst time speeding along. So that we're going to go to number 6 next. I have that one. That one's circled. Nobody got it right. And so I want to talk a little bit about this one. If you were stumped about this one, it may have been just, misunderstanding of what they were asking for. But if you go and watch April 10th's AP YouTube review, he does this exact same experiment. He puts an object on a rotating disc and he decides to try and figure out what's the coefficient of friction to get it to move. It's a great experiment, again, that they might use as a free response question for this year because it's got forces of friction, energy, tension, motion, lots of things that they could do with this type of problem. And the fact that they made a video about it and put it out there for the nation to review, definitely a good one to go back and watch. So again, April 10th. Here's the math behind it right here. So they're setting two equations together. This equation right here, I saw a lot of you guys go to this one on the free response questions for this section. Great job. You're thinking about tangential speed, and that's that v squared right here, which is really important. As we think about the things needed to measure velocity, again, the reason this is the best answer is because they didn't overcomplicate the data and collecting it. They kept it simple and used things that absolutely, at the bare necessity, would be needed to collect data. So again, we're just measuring the radius with a meter stick. We don't really care about the overall mass of the object because, as you can see here, the mass in this equation gets canceled out. So we don't need mass in our final equation. Okay, we definitely need something to measure distance. I already talked about that from the center, and then a timepiece. So how long does it take to make one revolution? So right here, and that's where your time is going to come in. Why do we need a stopwatch? Well, the time is how we are going to collect that velocity. Meter stick, again, is your radius, and then gravity, good old gravity, is just 10 meters per second squared on the AP exam. So don't overcomplicate that. By using 9.8, it's just plain old 10 to keep the math simple and easy. And this year they promise us none of the math will be done, period. You're just going to have to derive equations and type or write the equations out and rearrange them. So they're saying we're not going to make you do the math. If you want to do the math, you can, but you don't have to. Okay, next one is 6. Okay, I have 8 written down. This one, okay, 7 and 8 are similar to one another. This one was a really tough one, definitely, but I think it's related to the question 2 on the free response. So I just want to give you guys a second to look through how they derived this equation and how they used planet X and planet Y as a ratio to figure out how much bigger the gravitational field is compared to the other one. I don't really know if they'll put this one on there, but they might throw it at you if they give you satellites or stars or orbits. So this would be a good one to go back and put on a review sheet. All right, number 10, I'm going to skip over. Very few kids got that one right, but it had to do with particles, subatomic particles, and this really isn't a Physics 1 topic, so I don't think they're going to use it. But kids that have taken chemistry, that one might have made sense. Okay, here we go. This one, free body diagrams. When I went through the multiple choice, it just red flagged all over the place because you guys had a really hard time identifying the correct free body diagrams. Again, April 10th AP YouTube review is amazing. He does a great job of talking about those forces and what we call real forces. Now, this problem is asking you to sum the forces. So keep in mind, if these two arrows are in the same direction, we're adding those forces. If these arrows are in opposite directions, we're subtracting those forces. And in both cases, we are going to use centripetal force and Newton's second law. So again, F sub c is centripetal force equals mass times centripetal acceleration. And so here we have both of these equations for each of the free body diagrams. And then what do? We solve for F sub c and set them equal to each other. And that's what we see happening here. So that way we can solve for this centripetal acceleration. And that's where we get our correct answer. Okay. All right, number 11, that was a big one I wanted to share with you guys. Number 13, rocket thrusters. This one, I think it was just kind of backwards thinking with Newton's second law, where we're going to just plug in some known numbers to get this total net force. Again, keeping in mind that 10 is the number they're using for gravity. So in order for this to be true, your mass had to be 1 kilogram. And, okay, 15 is my next one. Block on a circle. We've talked about this one already, so it's very similar to what we saw before, where we're using that tangential speed here divided by r. A lot of you used this equation in the free response questions. It was the wrong one for that specific question, but it definitely is applicable to this problem. And so when we do that, if we double the velocity, okay, we square those terms and then it makes it times 4. In this case, your radius isn't changing, your mass isn't changing, but the speed is, and that's why this one is the correct answer. Okay, 17 is our next one. Okay, again, this goes back to number 2 in this review. A satellite in orbit, what is the only dominant force? Gravity only. And so this one is true. With free fall, we can reach terminal velocity, and that's because of wind resistance. Electrons and protons, again, I would just put these out of your mind. Unless you've taken chemistry or physics 2, that's not really a choice that I would pick. It may have confused you guys because of that, but I really don't think they're going to put anything like that on this year's exam. God help me if I'm wrong. All right, here determining the slope. We've got 40 divided by 5, that's 8, less than gravity, right? So we have a linear fit line here. Use that slope. So the slope of velocity over time, that's an acceleration, right? And in this case, it's the acceleration due to gravity that we're comparing it to. It's less than that. So correct answer, no, it cannot be. And then finally, number 20. All right, our planet and our moon. Again, gravity is the only real force here, so it has to be pointing towards the center of mass of that system. A lot of you picked this one. Centripetal force is not an actual force, guys. We talk about centripetal force, but there's always a real force that creates that. Again, April 10th, AP review, watch it. He explains that again. So we can't pick both of these forces. It's just one. Okay? All right, hope that helps. If you have any questions, leave it in the comments on the Google form, and I will try and address it next week. Thanks. Bye.